But we're going to find the perimeter of each of the following triangles. And the perimeter is the distance around. So if we look at this first triangle, the nice thing is we have all of these values. We've got 16 plus 19 plus 15. And we can add these all together. And when we do, we get 50. And I'm going to put the units on at the end, the inches. But what if we're not given all of the sides? We need to be familiar with what kind of triangles we're working with. So we need to go back and look at our marks on our triangle. This triangle is isosceles. And what isosceles means is that we have at least two congruent sides. And our tick marks will tell us here, since to the left is 5 yards, this is going to be 5 yards as well. And then when we want to find our perimeter, we can add 5 plus 5 plus 7. We end up with 17 yards of perimeter. Again, identifying what kind of triangle when we don't know what all of the sides are is helpful when it comes to finding the perimeter. As in our first example 2 here, it says find the perimeter of the triangle below, round the answer to the nearest tenth. Well, what we see in this particular triangle is that we have a right triangle. And when we have a right triangle, we know that we can use the Pythagorean theorem. We want to find the length of VW, which I'm going to call side A. You can call it whatever you want, but we're going to use the Pythagorean theorem. So this is A squared plus 7 squared equals 11 squared. If you need to, you type these values in your calculator. But 7 squared is 49. 11 squared is 121. And then we can subtract 49 from both sides. And we will need our calculator conceivably on this one. But when we subtract 121 minus 49, we end up with 72. And once again, a reminder, when we're squaring, we want to undo squaring, we need to take the square root. So we're going to take the square root. We're going to take the square root, and that's where Desmos or the calculator will help us find that the square root, second, and the x squared button, that gets us up to the square root of 72. Gives us this value here. And again, it says round to the nearest tenth. When we look at this, the tenth is 1 decimal space. So we're going to be looking at the 8 to determine what we're going to do for that 4. Is it going to stay 4, or are we going to move it up 1? And because that 8 is 5 or higher, that 4 is going to round up 1. So when we find the other dimension here, or the other side length, this is going to be 8.5. Don't forget, the idea is not to figure out how long VW is. The idea here is to figure out, well, what is the perimeter of the triangle, the distance around. So we can take the 8.5 plus the 11 plus the 7, and our perimeter, I'm going to put that as P there, 8.5 plus 11 plus 7 gives us our perimeter here of 26.5, and our units are feet. Watch out for the type of triangle. Can you figure out some side length, or do you have to do some computation to figure out a side length? But our second example 2 here looks like this. And this is where it really gets into distance again. And when we want to find the distance, we want to find the perimeter of the triangle graph below. And we don't know any side lengths, although we can figure out one of the side lengths pretty easily. And then when we figure out the perimeter, we want to round to the nearest tenth. This is 1, 2, 3, 4. That side length there is 4. So one of the sides is going to have a length of 4. And we don't need to do any computation. It's a straight counting process. But to find the other two sides, we do need to do some computation. And what we can do is we can draw in a value. You don't even have to make it dotted. I don't know why I just made it dotted. But I want to look at that triangle because what I want to find here is what's the distance between those two red points right there. And when we're finding the distance, what we're doing is we're using the Pythagorean theorem. So now that we have a triangle drawn in, this length here is 3. And this length is 1, 2, 3, 4, 5, 6, 7. So again, we're going to use the Pythagorean theorem. It's going to be 3 squared plus 7 squared equals c squared. Again, Desmos calculator, but 3 squared is 9, and 7 squared is 49. And then 49 plus 9 is 58. And we have to undo the squared. So we're going to take the square root of both here. And again, type it into Desmos, type it into your calculator. The square root of 58, we're going to round to the nearest 10. It's 7.61. When we're looking at this, we're going to look at the 1 to determine how to round. Well, the 1 is going to help determine whether we're going to leave the 6 alone or whether we're going to bump it up. And because 1 is 4 or less, we're going to leave the 6 alone. So our distance for our red triangle is going to be 7.6. So we know this side length now. We have to go through that process one more time because we need to find another side length. And I'm going to draw this triangle here. Again, it doesn't have to be a dotted line or a dotted triangle as the case may be. But this pinkish purple has a side length of 1 here. And we have a side of 1, 2, 3, 4, 5, 6, 7. And we're going to use our Pythagorean theorem. In this case, it's going to be 1 squared plus 7 squared equals c squared. And we get 1 plus 49 equals c squared. 1 plus 49 is 50 equals c squared. But we need to undo that square. And it might be nice if I wrote c squared. Undo that square after I get that over here by taking the square root of both sides. And that's when we pull out our calculator or the Desmos. And the square root of 50 is 7.07. But we're going to look at this 7 here to determine what to do to the 0. Because that 7 there is 5 or higher, then we're going to round that 0 up to a 1. So we end up with C equals 7.1. And lastly then, we want to find the perimeter of this triangle. We had to do a bunch of work to get to that point. But now that we have, we can add the 4 plus 7.6 plus 7.1, and we get 18.7. And I like to put a U after that just for units. Not going to be picky on that one because we're not given units. We were given units on example 1A and B in our first example 2. But remember, perimeter, the distance around. But on example 3, on the back of our paper, the nice thing about this triangle is that it is a right triangle. We don't have to find all, we don't have to work as hard, I should say, to find all our lengths. Because if I get this corrected here, we need not AD, but AC. So we'll fix that up. There, we want to find these lengths. Right now, we don't know what AC is. We can find it, but what we can figure out is how big is AB? Oh, it's a right triangle. So we have 1, 2, 3, 4. AB is 4. And over here, BC. 1, 2, 3, 4, 5, 6. BC is 6. And we want to figure out that other length so we can add these 3 sides together to get our perimeter. Well, Pythagorean theorem. Find the distance. 6 squared plus 4 squared equals c squared. If you have 4 squared plus 6 squared equals c squared, that's fine. 6 squared is 36. 4 squared is 16. And when we add these together, we get 52. And once again, to undo the squared process, we have to take the square root. So that's going to require us to type it into Desmos. It's going to, wrong color, but type it into a calculator. The square root of 52 gives us this decimal. And actually, the lining up, it worked out just perfectly in this one. If we look at that 1, because we're looking at 7.21, looking at the 1 to determine what to do to the 2, well, 1 is 4 or less, so we're going to leave the 2 alone. So this ends up to be 7.2. And that's what's going to go here. And when we're finding the perimeter, all that we're doing, we are going to take 7.2 plus 4 plus 6. We're going to add those together. Again, Desmos, the calculator, 7.2 plus 4 plus 6 will give us our perimeter, the distance around this triangle. And I'm just going to put U for units. So it's really nice when we have a right triangle because we don't have to do a lot of calculations. And the counterpart here is our last example. We have to find all of these distances. So we have to find CA, AT, and CT, and we're going to start by graphing these. And C is going to be 2, negative 1. So here's our value of C. A is 8, 1. There's A. And T is 7, 3. And we're going to connect those. And unfortunately, it's a little bit of a small triangle. But we can't just count our boxes to get the distance on this one. We need to figure out the distance of all 3 sides. when we start here, it says CA first. Kind of hard for me, but I'm going to try to draw in the triangle. It shows up a little bit better on your paper. But as I look at this, what I've got over here to the right is it's a distance of 2. 1, 2. And down below, we have 1, 2, 3, 4, 5, 6. So for CA, we're going to use the values of 2 and 6 for our Pythagorean theorem. I'm going to say 6 squared plus 2 squared equals c squared. If you prefer to do 2 squared plus 6 squared, it's not going to make any difference. You end up with 36 plus 4 equals c squared. 40 equals c squared. And then we're going to take the square root of both sides to undo that squaring. Here and here. So we end up with c equals, we're going to round to the nearest tenth eventually. Square root of 40 is 6.32. We're looking at this 2 here to determine what to do to the 3. But that 2 is 4 or less. So we're going to move that as 6.3 for that length. We need to figure out the length of AT. So I'm going to color code this here. So A is here, T is there. I don't know why I didn't mark the T. And our triangle, again, very small. But what we get is we get here and here. Very small triangle. And I see the length of 1 here and then 1, 2 there. So when we use our Pythagorean theorem, again, it doesn't matter if you do 1 squared plus 2 squared equals c squared, or vice versa. 2 squared plus 1 squared. Get 1 plus 4 equals c squared. 5 equals c squared. And then we're going to take the square root of both sides. So we'll type that in to either Desmos or our graphing calculator. Clear. Square root of 5. Second, and the x squared button gets us up to the squared. And the square root of 5 is 2.23. We're looking at the 3 to determine what to do to the 2. And because 3 is 4 or less, then we're going to leave that 2 alone. So this is going to be 2.2. We have to do this process one more time. We need to figure out what CT is. And our picture's getting a little jumbled, but hopefully we can be okay. I'm going to draw my triangle. So we're going to look at the distance between these two. I'm going to draw my triangle here. And what I see as I look at my paper as well and I've got to redraw my triangle a little bit, but maybe I won't. But really, speed this up a little bit. This point is at 7.3. Get that up there. I think that the distance here on this particular one, because we went from -1, because it's CT, -1 to 3, this distance is 4. And then 1, 2, 3, 3, draw 4, 5, Let me look at my paper. Yes, 5. There. So hopefully your picture is a little bit better than mine. But when we do the Pythagorean theorem, then we're going to get 4 squared plus 5 squared equals c squared. And that gives us 16 plus 25 equals c squared. And 16 plus 25 is 41 equals c squared. And we're going to take the square root of both sides to figure out what that value is. So we pull out Desmos, or we pull out our graphing calculator, and square root of 41 gives us 6.40. So that's nice. We're looking at the 0 to determine what to do to 4, but that 0 is 4 or less, so this last one is going to be the 6.4. And when we figure out what our perimeter is, we're going to take those values, the 6.3 plus the 2.2 plus the 6.4, and we're going to add those together. 6.3 plus 2.2 plus 6.4. You've got to type it in right. This is going to be easier said than done, but 2.2 plus 6.4. And we end up with 14.9 for our units. 14.9 units for our perimeter for the distance around.